From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture. Human activity can really change the shape of a landscape. You can think of just here in Oregon, the Willamette Valley. 10 years ago, who would have thought there'd be so many acres of hazelnut or hemp or wine grapes? And when you span this time series out even further, you can think of the oak savanna that was in the Willamette Valley before, which many of our pollinator species grew accustomed to in evolutionary time. My next guest thinks deeply about these questions and about how land managers can reverse these effects, how they can encourage some of these insects to return to manage landscapes. Megan O'Rourke is an associate professor in the School of Plant and Environmental Science at the College of Agriculture and Life Sciences at Virginia Tech. She's been approaching the problem from various directions, but most recently she was awarded a prestigious National Resources Conservation Service Conservation Innovation Grant to tackle a really big issue, namely the fescue belt, which stretches 1,000 miles across the southeastern United States from Virginia and Carolina in the east to Kansas and Oklahoma in the west. In this episode, you hear about some of the challenges, but also some of the opportunities that pasture managers may gain from putting pollinator habitat into their grazing systems. Paired with the previous episode with Dr. Serkan Atez, there's some really great ideas here for pasture managers in Oregon on how to create dual-use pasture that makes livestock more efficient, but also helps pollinators. Hope you enjoy the episode. So pollinator diversity and agriculture are frequently pitted against one another. Is this just one of those wicked problems? What is this kind of, we always think that agriculture and biodiversity don't go together. Is this true?
So one area of thought is that we should concentrate all our production in as small as area as possible and almost make it like a factory where it's just focused on production and high yield. And the idea there is that we would then allow more land to be set aside for pristine habitats. So on the other side of thinking is that we could actually integrate conservation into agricultural landscapes. And I tend to lead towards the latter. So in my experience, we can both have agriculture that's beautiful and biodiverse and complex, and that can produce both food and other ecosystem services like pollination. And I think that pitting this idea of like you can only have conservation or you can only have agriculture is kind of barking up the wrong tree. Uh-huh. So one question that I like to pose out there is, do we need to actually be producing as much food as people say? So maybe the audience members have heard, we need to produce 70% more food or 100% more food by 2050 to feed the growing population.
Oh, yeah, sure.
Well, if you look at that, if you kind of deconstruct those numbers, we're only really expecting an increase of about 25, 30% more people. So the estimates for increased food production are coming from somewhere else. And it's really been based on economic modeling saying that people are going to grow more wealthy and they're going to want to eat more Western diets that are heavy in animal proteins. And then there's also all this increase in biofuel usage. So,
right. Yeah, sure.
Yeah. So between both of those things, I think we actually need far less extra food than the economists are kind of saying that we do. And so that kind of changes the equation of we need more land. Do we really need more land, or can we focus on producing what we need, not overproducing, and also then focusing on conserving while we also produce food?
That's really interesting. So if I get this straight, there is, and I've heard this before, where people are like, well, we need like wildlife reserves and then intensive agriculture, and that's one model. But the other one is that it's possible that agriculture could be blended into conservation in a way. And in fact, one of the rationales is that it has to be intensive, otherwise we won't hit these food targets. But maybe we don't. There's a kind of way in which the way forward may involve putting biodiversity back into farmlands. It's not as wicked a problem as one might think at the outset.
Yeah, I think it's really a multi-pronged approach, right? First, we need to figure out new techniques in order to integrate conservation effectively into agriculture. So, there's been some debates that I've seen on Facebook lately about people saying agriculture is really easy, just plant some seeds and water them and it grows, right? But I think anybody who's in the field knows that that's not the case. And so when we're trying to do not just food production, but we're trying to maximize these other benefits for wildlife conservation and such, I mean, it becomes a really kind of intellectually intensive, information-intensive process. So I think we need an emphasis on really that research on how to produce food while simultaneously having conservation benefits. I think we need to question this paradigm of having to produce so much more food into the future. And then I think, specifically on this beef-friendly beef project that I'm working on, I think there's various opportunities if we're doing conservation agriculture to actually create a premium on the products. So hopefully, beef-friendly beef. Is that something that consumers are willing to pay more for? And could that then be used to offset some extra costs that farmers might incur for conservation?
I have to tell you, the term beef-friendly beef does actually, I like the sound of it. Tell us a little bit about the systems that it sounds like you're really trying to tackle this issue in your research on a really large part of the U.S. land base. Tell us a little bit about how this land is managed for beef production and some of the constraints that you were talking earlier that agriculture is not as simple as just putting seeds in the ground. Tell us a little bit about the constraints that those producers face.
Yeah, absolutely. So I'm located at Virginia Tech, which is in Southwest Virginia, and it's right in the center of the fescue belt. The fescue belt is this area. If you kind of look at a map and you start from Virginia down to South Carolina, and you draw an oval out over to western Kansas or eastern Kansas and Oklahoma, that whole area is considered the fescue belt. And it covers about 37 million acres in the U.S. and intersects 16 different states. And I'm a little bit bashful to say that as an academic, I didn't actually know much about the fescue belt until I moved here to Virginia as a professor. And so if you think about the natural landscape of the eastern U.S., right, the ecological system would really be a deciduous hardwood forest landscape. And so, we've transformed it into this cattle production, animal production area, but it's not the natural landscape. So what happened was that in the 1800s, people brought over grasses over from Europe, including fescue. And it didn't actually take off until 1931. There was a professor from the University of Kentucky who found some fescue grass growing on a kind of rocky, poor soil hillside. And he started to develop it for more widespread production in the East. So by the 40s, it really took off because it has some really excellent characteristics from a production standpoint. So it's very drought resistant and it's resistant to insect and disease. It persists well. It has really high production, but it's non-native, right? And so it's kind of, from a plant conservation standpoint, certainly not what we wish that 37 million acres across the Southeast was covered with. It has this really cool relationship with a fungus. So it has this mutual relationship with a fungal endophyte. And this endophyte, it like lives between the cells of the fescue grass. And it produces this alkaloid. And so an alkaloid is this defensive compound that actually really helps in pest management, protecting it from things like herbivory.
I'll be darned.
Yeah, but so the crazy thing, on the flip side is that it actually causes something that we call fescue toxicosis.
Uh-huh.
So as the plant starts to mature, these alkaloids build up in the seed heads, and as the cattle graze and later in the spring and into the summer, they can get really sick. So you'll see cattle, their winter coats won't really slough off, and essentially they're unable to dissipate heat well.
Oh dear.
So they'll be standing in water. They won't be eating. So it's estimated that this causes like $1 billion of losses in cattle production each year, and that about a quarter of all cattle are affected by this problem. But at the same time, it produces pastures that are really productive, and so that trade-off is this major issue in the fescue belts of the United States.
Okay, so they've got they have a cropping system that has really, the one issue is it has displaced a lot of that native forest. So there's been this land use change, which we've seen all across the United States. And it is it sort of has this virtue of being a system that is less inputs in some ways because it has it's for whatever reason it's suited to this growing environment, but there is this problem. The same thing that makes the plant kind of thrive and be low, easy to manage, also is causing this problem to cattle.
Right.
Holy
exactly.
smokes! Wow. Okay, so tell us a little bit about. So this is the context of the research that you're going to be doing. Where did you get the idea for doing this? I imagine this this issue with the constraints that the growers comes into it. But when I think about pollinator habitat, most people are focusing on high value cropping systems. I'm thinking about right now in almonds, we've got brassicas that are growing in rows, or up in Michigan having pollinator habitat on the edge of blueberry fields. We did just have an episode here in Oregon. We're interested in the same issue, but we don't hear about pasture management. So where did this idea come from, and how does it mesh in with this system that you've been thinking about?
Yeah, so I started my position here at Tech in 2013, and some of my first big project that I started actually was more along the lines of the type of projects that you described that have been more traditionally studied. So I was looking at pollinator habitat on small diversified vegetable farms and looking at impacts on squash and on strawberries.
Oh, okay.
And so that was great. I got a lot of really interesting information from it, but the number of vegetable farms and the acreage that it covers, I just wondered whether that work would have realistic impact in terms of large-scale conservation value, right? Because these small vegetable farms, they don't have much land to give away towards pollinator habitats. They want to mostly, give small areas of marginal land that they might have. So when I thought about making a difference across the landscape for pollinator conservation, I started to think, well, what is all across the landscape, at least in the region that I'm in? And that's when I started to reach out to pasture management specialists here at Virginia Tech, who's been working in grazing systems and looking at forage production for his career. So that was probably back in 2016 when we started launching this crazy idea of, well, maybe we could start planting flowers in the pastures and maybe the farmers will like it. And so we actually have a few projects already. And first one was a state conservation innovation grant back in 2016 that my colleague Ben Tracy started. And then we have a crazy project with engineers using drones to see if we can assess, do pollinator surveys and plant sampling surveys using drones.
Oh, really?
Yeah,
oh, that sounds
really
cool. Yeah, I'll ask you about that later. That sounds fascinating.
And then my colleague Ben, he got a NIFA, USDA NIFA grant to work on warm season grasses, rotational grazing of warm season grasses, and incorporating some of these pollinator habitats into grazing systems. And now we have this big new conservation innovation grant. So there's kind of a series of projects that really took off, I would say, in the last 4 years. And I think we're having so much traction because the idea is pretty unique and there's not a lot of expertise yet in both pollinator conservation and grazing systems in the U.S. at this point.
And such a large, I like the way that you sort of made that transition from, high value crops where there isn't a lot of land to spare because, you really have to get as much value off that piece of land as possible to these larger, less intensive livestock pasture systems where there does seem to be an opportunity to fit things into those systems and also affect a large land base.
Yeah, imagine 37 million acres being transformed. I mean, we know that habitat loss is one of the major drivers of our problems with pollinators right now. So, I mean, yeah, I don't know that it'll roll out on 37 million acres, but that's the dream, right?
I agree. Well, let's take a quick break and let's come back. I'd like to know, I think all our listeners are really excited to know a little bit more about how to sort of tackle this problem of 37 million acres, how the research is going to address some of these questions. So let's take a quick break.
Great. Yeah.
Okay, we are back. So we were talking about this big crescent, this big system of pasture land that really could make a lot of impact for pollinators. You've been awarded a NRCS Conservation Innovation Grant, a very competitive national grant to address some of these questions. Can you kind of lay out some of the key questions that if you were a pasture manager who wanted to do bee-friendly beef or something, what are the kind of key constraints that you'd face and how that your research will be addressing?
Yeah, I think from a manager perspective, the big question is how the heck do I get this planted? How do I manage it? And how is it going to affect my cattle productivity? So those are really what we're trying to address from a production standpoint, and those economic constraints. The reality of whether this is going to get adopted large scale is going to be, does it fit into the existing system of cattle production? And then on that conservation side, we're looking at how is this going to affect pollinator conservation.
Okay, so when they're looking at this question of like, I don't want this to cost me a lot of money, but I want to make an impact. If I'm going to put some resources into this, I imagine the first question that comes to a lot of people, or the key questions are, what plants and how do I get them started? Is that how are you addressing those questions in your experimental design?
Yeah, so we when we put together this proposal, we went through an exercise of going through all the commercially available seeds from big suppliers, which are Roundstone and Ernst seed companies. So we wanted to make sure that we weren't picking species that were pretty obscure and farmers wouldn't want to buy.
Mm-hmm.
And then we cross-checked that list with palatability to cattle. We definitely don't want something that's toxic to cattle out in the pastures. And then we looked at the Ladybird Johnson pollinator value website. And so we kind of cross-checked those three criteria.
One more time, you looked at the Ladybird. What was that? I don't actually know this resource.
Oh, it is the Ladybird Johnson website.
Okay, we'll put it in the show notes for people to look at. Okay, great. So you looked at availability, you looked at palatability to livestock, but also its benefits to pollinators. So you came up with a short list. Okay, keep going. Sorry to interrupt.
Mm-hmm. So it's 20 species. It's 14 flowering forbs and 12 flowering forbs and 8 native legumes. And of course, they have to be native.
Okay.
The criteria also. And so we know from past experience that not all of these are going to work. First of all, they're very variable in their cost. We know from previous experiments that I would say on average, if we plant out 10 species of wildflowers, that maybe 5 or 6 will establish. Um, but maybe not always the same ones in different places. And so that's why we are working in different areas of the fescue belt with these 20 species to see if we can consistently recommend some over others.
Mm-hmm.
But we hope there'll be a shorter list that's both economically feasible, persists well, flowers well, has high value for pollinators, and it's good for the cattle production.
Okay, so I know the award has just come out. Can you tell us about the steps that we? So I imagine you're going to need to seed some of this out. How do you seed into these pasture systems? Is it a matter of like turning everything over, or are you seeding into existing pastures, and what time of year? And give us some of that detail.
Yeah, so the award was just announced in December, and we are all go and scrambling to get this launched, right? We're recruiting students, I'm recruiting a postdoc, we're having project team meetings. And the first experiment that we're going to do will go in this spring, and it'll be an establishment trial. And so we have 2 locations that we'll do it on, a standardized, randomized, complete block replicated type experiment. And we have a bunch of different treatments for establishment. So we want to look at different herbicide chemistry. So what we need to do is knock back the fescue in order to allow space for the wildflowers to become established, right? We know offhand if you just try to go into a vigorous growing fescue field and throw out seed, nothing's going to grow. There's not that open niche for something else to grow. So we have to knock back the fescue, and we're going to try a bunch of different herbicide chemistries. But we also want to have an organic option. Mm-hmm. So we are going to do some strip tillage. The problem around here is really that it's quite hilly and it's quite rocky. So I'm 100% supportive of organic. It may not be the most feasible method in terms of, problems for soil conservation. You don't want to plow up a hillside, really. So we will.
And I suppose one way to look at this for people who are like, oh, herbicide, I guess the thing is that this is the one-time sort of establishment that you really want. You're going to get the benefits for a long time down the line.
Mm-hmm. And we're not trying to kill it. Like, we're not trying to kill the fescue field. We're just trying to knock it down. So it'll be a fairly low dose.
Yeah, and that's a fascinating establishment challenge. One of not trying to kill the plant, but trying to give it a little bit of a break so that the forbs can come through. That's a really novel, interesting weed management approach.
Well, the other thing that we're going to try, and hopefully this could contribute to our understanding of organic methods, is trying to winter stockpile the cattle. So, just the hoof action over winter will knock back the fescue too. So maybe that would be another organic method in addition to a strip tillage. So those are our 2 organic possibilities.
I was actually just one plant is not a native that people are interested for its anti-helminth properties is chicory, and we were just out at a pasture 2 days ago, and it was a matter of using the hoofs as a way to get to seed in the chicory because you do have this opening. It's a fascinating. That's an interesting method. I guess the strip tillage is kind of like just kind of running a line down and going through the line.
Yeah, I'm really interested in the uniform integration based on this idea of complementarity between different functional groups. So, research has shown if you have a diverse mixture of different plants, you can actually get more production, more biomass production than if you just have a monoculture of one thing. So that's what kind of excites me, if we can intersperse the flowers throughout the pasture, that hopefully we're not going to actually reduce the production of grass in the same way that we would if we clearly take a whole strip of grass out of production and just plant it to flowers.
I suppose the other thing, I'm so sorry to dwell on this because it seems, but we do get a lot of questions from listeners on this. The issue is often that with a lot of these forbs is grass it tends to lose ground to grass. So in some ways, I guess inevitably the fescue is going to come back, or you'll find this out in your experiments. But I imagine that it is for listeners who don't quite appreciate the challenge of getting forbs into grass areas, it's not easy.
Yeah, and that's why we have an aspect of our research that will be a long-term persistence trial, where we're really lucky that we're able to piggyback on an existing trial that has looked at wildflower and grass pastures for 3 years already, and we'll have another 3 years. So we'll have this 6-year data set that I think is really unique out there.
So you'll be able to look at these different treatments and be able to say, well, not just the first year we got a good establishment, but if we did this kind of establishment treatment, we really get a plant community that's robust at the end. That's really great. That's fascinating. Well, so how about evaluating the effects of these on these pollinator communities? I guess one of the questions is that if we did this, we would increase pollinator diversity. What are you doing on that round?
Mm-hmm. Yeah, I'll be doing kind of typical surveys. So NRCS actually has a kind of a standardized pollinator survey protocol where you do transects into the field and you go for a certain amount of time and you count up the number of honeybee and other bees that you see. So it gives you a good and pretty fast estimate of abundance and diversity. Well, that abundance is a proxy for diversity. Mm-hmm. And then we also want to do some more detailed surveys of actually going and trapping the bees and identifying species and comparing the community composition in these wildflower enhanced fields and conventional fields.
And we were talking at the break, there is this dimension of setting up these treatments and evaluating them, but it also sounds like this project also is going to include a number of producers as well and doing some comparisons. Can you describe that part of the project?
Yeah, I guess backing up, I'd say it's a 4-part project.
Okay.
Part 1 that we're starting right now is this experiment about establishment. Just how do we get these flowers to grow well? And then we're going to do side-by-side feeding trials, both in Virginia and Tennessee, of pastures with and without wildflowers, and really track the impact on cattle weight gain. And then we have this experiment that's already been going on in Tennessee for 3 years, and looking at the long-term persistence of wildflowers over the next 3 years. And then the 4th kind of experimental unit of this project is working with growers in Northern Virginia to look at on-farm trials. And that we're pairing up with a nonprofit called Virginia Working Landscapes. And they have found 3 farmer cooperators who've already signed up and signed all these agreement forms. Yeah, and I'm actually really excited too. We have 2 nonprofits that we're working with, including the Jefferson Foundation. So, Monticello, we're going to be like.
Oh yeah, planting. That's right. You're in Virginia, of course. Yeah, that's great.
The beef-friendly beef is going to roll out on Monticello.
Wow, that's amazing.
Yeah. And so on these big ones, we're looking for at least 20 acres on these on-farm trials, and we'll do half with wildflowers and half not with wildflowers. And because of the dispersive nature of insects, it's best to do these pollinator surveys on larger areas. So we'll concentrate on the pollinator impacts on the on-farm trials.
That's amazing. Yeah, the one thing I did want to, I was at I was visiting a pasture the other day, and somebody pointed out that just dry mass does not necessarily mean weight gain. That even if a pasture is really putting out a lot of dry mass, there's all sorts of things that cattle can eat that can increase their efficiency and allow I think they were talking about plantain specifically, another non-native, but that there's some evidence that some of these plants, although they don't have a lot of mass, they really allow the cattle to generate, to be more efficient in their digestion and everything.
Right. Certainly, just massive toxic fescue can be very detrimental.
Oh, that's coming right round to so you did mention that right at the beginning that some of the fescue may in fact, on its own pure may affect the weight gain. So do you hypothesize that some of these plants may offset that? Yeah.
So the best case scenario, right, is that Right now, cattle producers integrate clovers into their pastures to offset some of this toxic fescue toxicosis impacts, and also to produce like a more nitrogen-rich feed. And so that's already one way to manage fescue toxicosis. And so we're hoping that with these wildflowers incorporated into the fields, also that it could have a similar effect where, a cattle will be grazing less of the fescue because there's other things to be eating. And that it will take native wildflowers and replace non-native clovers in these systems.
Oh, so even if that pasture is not turning out as much dry matter per day, they potentially may eat some of these wildflowers, offset that toxicosis, and actually gain more weight.
That's the best case scenario, right?
I'm cheering for it.
we're hoping there won't be detriment to cattle production, right? That's the worst case scenario. We do this research and cattle weight gain is way lower for whatever reason, and these fields turn super weedy. That's the worst case scenario. A neutral case scenario is that at least as good as regular production. And the best case scenario is we find these extra benefits, and one of which could be offsetting this fescue toxicosis problem.
Oh, fascinating. Well, I guess the thing, this is why NRCS funds this kind of work, that NRCS is really looking for better practices that it can roll out in its conservation programs. And if you are able to show either positive or negative, it does help them. Can you maybe talk a little bit more about how NRCS specific practices may, be influenced by this work?
Yeah, I'm super excited about this project and working with NRCS because their goal with these conservation innovation grants is to change their conservation funding model. So right now under a program called EQIP, Environmental Quality Incentive Program, NRCS funds about $2 billion of on-farm conservation a year. So what they do is they'll enter contracts with farmers to cost share implementation of conservation and also to provide technical advice of how to implement conservation. And so they have like this book they go to that are conservation practice standards, and there's over 100 of them. And there's one in there that's called the forage and biomass planting. But if you look through it, there's nothing about integrating wildflowers into forage systems. And then there's another practice called the wildlife habitat planting conservation practice standard. But that's more like taking land out of production and turning it into a pollinator habitat. So they don't currently have any system of funding right now that would integrate pollinator conservation into animal production systems. And so if we can rewrite those rules, which in fact is what NRCS wants us to do, that triggers the ability for NRCS agents around the country to then enter contracts with farmers and get this going.
And I suppose for that to happen, the local agents need to feel confident that what they're recommending they can pull off. And I guess this is doing these trials both at the establishment stage and how long it persists, and actually having this partnership with the nonprofit and doing these paired trials will really kind of allow those agents to feel more confident when they make the recommendations.
Yeah, and part of the project, we've incorporated budget to do a lot of outreach. So we're going to do field days, and we're going to be inviting NRCS agents throughout the fescue belt and sending information out to them and doing webinars and partnering with the national NRCS up in DC to rewrite these rules and rewrite these regulations, presuming, of course, that the experiments go well and that we're not in a worst case scenario outcome of the research.
Well, I wish you the best of luck with this. Let's take a quick break and come back. We have a couple questions we ask all our guests. We've never had a pasture pollinator. Well, we have, but we never asked them the question. A couple episodes we had Serkan and Tez from here at OSU, but I'm curious what your answers are going to be. So,
Okay.
Take a quick break. are back. So I've got three questions for you. They're questions. So the first question is, do you have a book that you want to recommend to our listeners? Is this a book that you really think they'd benefit from reading?
Yeah. Well, right now I'm working on a book called The Solitary Bees, and it's by Brian Danforth, Robert McKinley, and John Ness. And I think it's really cool just because, there's a whole world of bees out there besides for honeybees. And it just goes into the phylogeny and their relationships and the nesting habitats. And it's just super interesting. And they try to bring together like stories. I hate to say this, from a little bit of obscure literature, not just like Wowie Zowie Science and Nature, but kind of smaller regional journals, and bring together that natural history of solitary bees.
That's a great description of it. I do think there is a lot of esoteric, and they say that in the foreword, and we had Brian on a previous episode, that there is a way in which they really wanted to go through the literature of things that were maybe a little obscure and bring it to the fore, that they didn't want it to get lost. But I find that the writing style as well, it seems like a daunting book because it weighs a little bit.
Yeah, I haven't read it cover to cover. I'm working on that. But it really, I think, bridges this really cool divide between being technical enough to be a scientific book, but also accessible enough to being kind of fun to read too.
Yeah, for sure. I completely agree. That's a great recommendation. Our next question for you is, do you have a go-to tool for the kind of work that you do?
Interesting question, because when I thought about it, I was like, do I have any tools? So I'm a super field ecology kind of person. I have quadrat squares, and I have nets, and I have trucks to get to the field site. So I would say whatever is really low tech and can be put together with some glue. Those are my tools of choice.
Well, a quadrat is an important thing, I have to say, in terms of, imagine characterizing those plant communities, those plots, trying to figure out in an objective way, not just eyeballing it, how many of these plants are coming up. What does your quadrat look like? How big is it, and how do you use it?
Oh, I have a whole assortment of them. 1 meter square, quarter meter square. I have ones with strings subdividing sections of the quadrat, so I can do select counts within the quadrat. That basically looks like white PVC with purple glue in the corners, and just gets thrown out to the field.
I am not a plant person, but why does one need so many different types of quadrats? Which I guess, just to describe to listeners who don't, it's just it's a square of PVC pipe.
Yeah. So it designates an area in which you're going to say, this is the number of plants or the types of species in a specific area. So it helps you really mark off, this is exactly 1 meter or exactly a quarter meter or something. But it kind of depends on the plants and the density of plants and the size of the plots, whether it's most suitable to use a larger quadrat versus a smaller one. If you have plots that are only, say, 2 by 5 meters, it's hard to take a bunch of 1 meter square, because sometimes you're like clipping the plants, and so it becomes tricky, and then you just have to think about the experimental design to make sure. So I capture enough diversity with a small quadrat, or am I disturbing the area too much with a large quadrat? So
fascinating! Wow, that's really cool.
Super high tech too. I mean, I would say one quadrat must cost at least like $1.
I love, we really try to encourage our listeners that there is a lot of questions that could be answered with, you do not need a fancy molecular biology lab to answer some questions that are completely unresolved. There's a lot of low-tech ways to answer very interesting questions.
Yeah, absolutely. I tell my students it's all about careful observation. I'm a field person, so just being out in the field, observing, questions come to you when you spend time out there. And then, my job as a scientist is to then precisely quantify the answers to those questions, as opposed to have a vague notion of this or that.
So our last question to you is, do you have a favorite pollinator species?
Yeah, I wanted to be cool and have some native pollinator or something, but I'll just be frank that I'm an agriculturalist at heart, and I love honeybees. Um, and I think they're such an interesting species from my perspective as an agroecologist, because they're kind of pitting this invasive species. Honeybees is basically this non-native invasive species in the United States that potentially interfere with our native species and our native ecology. But so is all of agriculture. So for me, it fits my whole interest in this balance between conserving the native bees while also having production agriculture in a way that people have demand for. And I love honey, and I love playing with my bees. I have beehives at my house, and they're awesome.
That's a great answer. Thank you so much, and thanks for taking time to talk with us. It sounds like I'm really looking forward to catching up with you in a couple of years to see how the work goes. I know there's livestock management is the biggest agricultural sector here in Oregon as well. So we're looking forward to catching up with you in the future.
Great. Thank you so much for having me.
Good luck with your research.
Thank you.
Thank you so much for listening. The show is produced by Quinn Sin-Neal, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.